A bio-revolution is coming. If the last century belonged to physics and digital technology, many see the 21st century as the age of biology.
With 3D printers and synthetic biology, guess what? The information revolution is coming to biology.
A revolution that has the magnitude of the Industrial Revolution with the speed of the digital revolution. And many are saying it is the biggest business and investment opportunity in all of history.
If you really think about all the big 21st century problems like pandemic prevention, food technology, food security, ocean health, climate change, biology is going to play a role in all of them.
Biotechnology companies in the West are harnessing the power of big data and artificial intelligence in order to develop new drugs and products. Pharmaceutical companies with patented cancer and heart disease drugs generate billions in revenue each year. But the US and Europe may not lead the field for much longer. China, as is the case in other technologies, is catching up fast.
The distance between the US biotech company and the Chinese biotech company is getting closer and closer.
Over the last decade, the People's Republic of China has already made huge advancements in its biopharmaceutical industry.
China now is the second largest pharma market in the world. Specifically, the growth rate significantly higher than the other markets like the US.
But its ambition to go from manufacturer to innovator is only just beginning. China is emerging as a formidable force for biotech innovation, and in the coming years, the balance of power in gene editing and synthetic biology may dramatically shift.
It feels a lot like 1994, and there's this thing called the internet, and that's where we are in synthetic biology. It's just before this part of our economy is going to launch and change everything.
While Silicon Valley was the greatest benefactor of the internet age, China is making massive investments to be the home of the bio-revolution in 2030 and beyond. China is home to one of history's oldest medical systems, with traditional Chinese medicine such as herbal treatments and acupuncture dating back more than 2,000 years. Now, China wants to dominate the biopharmaceutical industry of tomorrow.
When I started the first company 19 years ago, at that time, most of Chinese pharmaceutical company doing the generic drug.
I would say more than 95% of medicine in China was generic products.
Production, manufacture, and almost no innovation drug research.
You know, in the drug industry, there's kind of a rough divide between the companies that really deliver the innovations and then patent these drugs and have exclusive rights to sell them, and then other drug developers that copy unpatented drugs and sell them around the world. And at the start of the century, that was kind of where China was.
For the Me Too or fast follow drugs, you don't have to do a lot of the research. You already know. But for first in class, you know nothing about that.
Well, when you have a breakthrough drug that is patented, obviously you're going to make more money on it. But it also can have kind of a cascading effect where if you develop a new area of research, you can kind of build on that and then have one kind of breakthrough drug after another.
This was the case in the US and Europe for companies like Merck, Johnson & Johnson, and AstraZeneca. For example, Merck's immunotherapy cancer drug, called Keytruda, delivered more than $17 billion in revenue in 2021, making it one of the most profitable drugs in history. But the research needed to develop these first-in-class drugs takes time and large capital investments, which in China in the early 2000s was difficult to acquire.
At that time, the real estate was booming. People make lots of investment in areas that easier to have a good return instead of in biotech or biopharma.
Michael Yu is the CEO of Innovent, one of the earliest biotech companies to emerge from China.
For the investment in biotech or biopharma, because of the risk for the investor to take is too high, and the return take too long to generate a return. And plus, biotech, the capital market was not open for any company who has no profit.
While a less risky business venture, focusing on creating generic drugs meant China was also losing some geopolitical power by relying on the drug industries of the US and Europe. China's 1.4 billion population is aging, and the country faces high smoking rates and serious air pollution woes, creating big public health challenges for Beijing.
Biotechnology is one of the 7 strategic emerging industries that the Chinese government earmarked in its current 5-year plan.
In the mid-2010s, you saw a concerted effort by Beijing to improve China's competitiveness in all manner of strategic industries. Drug development was obviously one, AI was another one. At the same time, you saw a big push into renewable energy and electric vehicles. And today, China is now the biggest EV market in the world.
In order to achieve the same success in the biopharma industry, China first focused on bringing its regulatory standards more in line with global benchmarks.
Basically told its pharma companies that they had to match what the West was putting out. At the same time, they streamlined the Chinese, drug approval process to give companies more of an incentive to get their drugs out into the market. So combined, these things both improved the quality but also the speed of Chinese drug development.
So that moment, I would say that changed everything. For R&D application, used to be they take 1 to 2 years. I remember one of my applications took about 19 months, but now it's 2 months.
In 2017, China would also join the ICH, an international group of the world's regulators designed to harmonize drug development around the world.
What that means is that we follow ICH guidelines and regulations so that the drug we develop is in compliance with global standards, leading to a second change, which is capital market.
Starting in 2018, companies like Innovent were able to list on the Hong Kong Stock Exchange, and later the Shanghai Stock Exchange Star Market. And since then, money has flowed to these biotech companies. According to a McKinsey report from October 2021, the market value of publicly listed biopharma innovation players from China across major stock exchanges has surged from $3 billion in 2016 to more than $380 billion in July 2021.
There's a tremendous amount of investor money, both within China and around the world, coming into the Chinese biotech system because China is the second largest healthcare market in the world. Its population is 1.4 billion.
And as that population ages, one of the biggest risks is cancer. China accounted for an astounding 30% of cancer deaths globally in 2020. Since those 2015 reforms, though, more Chinese companies have been able to provide increased competition in the form of lower prices. In some cases, being able to sell products at a third of the price of US competitors.
Past 5 years, and more biotech company in China starting to do the first in class.
Dr. Wang is the CEO of Jacko Biopharmaceuticals. He views their research as not simply providing more competition, but part of a global pipeline for new drug development.
We try to do the in-house research. We set up the lab in Beijing, Boston, and that way we can have the more opportunity to collaborate with the global big pharmas.
One of these collaborations is a partnership between Jacko Bio and US-based AbbVie to help fund their research into SHP2 inhibitors. While the financials of the deal weren't made public, Jacko Bio will receive funding for its research, while AbbVie will provide its expertise in global development and eventual sale. Additionally, Jacko Bio has the ability to learn and grow, so that potentially it can become more than just a research group.
So far, we are kind of clinical stage pharmaceutical company, but we are building up our own manufacture facility. And even in the future, we are thinking about build up our own marketing and sales team.
Innovent has also had a strategic partnership with Eli Lilly and has seen significant growth.
There's a dramatic change in last 10 years. We have 6 products on market, and we generate multiple billion RMB in revenue. And we have the manufacturing capacity, largest scale, and we have over 6,000 people now in our organization.
While growing quickly, bio research in China is still behind the West. Most publicly, this has been seen in the area of vaccine research for COVID-19. China successfully administered 3.2 billion doses of its own vaccines, fully vaccinating around 87% of its population. However, these use an older method that has proven far less efficient than the mRNA-based vaccines developed in the US and Germany. With the Omicron subvariant of the coronavirus now spreading quickly across China, Beijing is again enacting strict lockdown measures. But as China is still growing its biotech industry, biotechnology itself is in the midst of a massive evolution.
Biotechnology is really the marriage of biology and technology. And more specifically, it's this confluence of various disciplines over the last several decades where IT, artificial intelligence, software engineering, automation are kind of colliding with the world of biology to design biological systems that improve our lives.
One of the biggest areas has been the addition of AI computing to the drug industry.
AI and application of AI technology going to help drug discovery and drug development. And a very good example is the technology developed by Google.
Developed by a group at Google's DeepMind, AlphaFold was an incredibly sophisticated AI computing system that was able to dramatically reduce the time it would take to predict the shape of a protein.
Used to be, take months or years to resolve a structure for a protein, based on the old traditional technology. But now the technology developed by Google, you can do that in hours or days.
A team at MIT was also able to use AI to screen 100 million chemical compounds in just a few days, and were able to identify a powerful new antibiotic. With our increasing ability to process biological data, a relatively new discipline has emerged, called synthetic biology.
So synthetic biology, or bioengineering, is really amazing. Essentially, it's become cheaper and faster and easier to digitize biology.
Inside of every cell, every bacteria, plant, animal on planet Earth, is digital code in the form of DNA. Right? So it's A, T, C's, and G's, but you can read that code with DNA sequencing, and importantly, you can write that code.
Jason Kelly is the CEO of US-based Ginkgo Bioworks, which works with companies to design cells and microbes for new drugs and consumer products. Synthetic biologists increasingly view cells as biological computers with software programs encoded in DNA. If you can debug that code, you can possibly cure diseases and make better products.
For a bio nerd like me, this is magic. You literally go on a computer, you type ATC, GGG, you hit print, and out of machines like in this facility or the ones next door, comes a piece of DNA that's exactly what you ordered.
Using this technology, researchers were able to resurrect the scent of an extinct Hawaiian flower by extracting the DNA that encoded for the smell and placing it into a bacteria that it could then grow. But it's also allowing drug makers to automate more and more of drug discovery.
The development of this field is fascinating. You're enabling people to do a lot of things which they cannot do before. For example, you may potentially synthesize more compounds for you to screening. That potentially increases the success rate of drug discovery.
The applications of synthetic biology go way beyond just drug development. Think about meat being substituted with plant products. Think about biomaterials that could be used in manufacturing and even in the construction of our homes.
The promise of synthetic biology is that we can use our knowledge of biology to engineer better versions of organic materials like animal meat or even wood, or replace non-biological items like plastic or airline fuel. The possibility exists too to create a biological solution to climate change. In a 2020 report, McKinsey estimated that 60% of the world's physical inputs could be made through biological means, and that in 2040 to 2050, the direct economic potential would be between $3 and $5 trillion.
Just like we didn't know what uses the internet would have in 1994, there are so many potential positive uses of synthetic biology today that we're just starting to scratch the surface.
A lot of people talked about Moore's Law kind of being a game changer in IT, and that was a reference to the power of a computer chip increasing exponentially, but also the cost tumbling down. If you look what's going on in the tools that are used to design biological systems, it's actually even more dramatic than with Moore's Law.
But the speed at which this technology is being democratized worries some in the international community.
Synthetic biology is 99.9% promise. It's amazing how positive the impact will be on our lives. But there's that 0.0001% opportunity to misuse biology.
One of the biggest factors in synthetic biology is how easy it's becoming to use the technology and access information.
There was a group of scientists in Alberta, Canada, who in 2018, over a period of about 6 months and $100,000, they were able to recreate an extinct virus that causes horsepox. And in doing so, they showed that we can recreate smallpox, or the variola virus that causes smallpox. But that information, that blueprint for these most dangerous viruses, most of it is in the public domain, and that gives information that could be seriously misused.
Making things worse, the rate of technological development means the cost of such experiments are dropping dramatically. And where 4 years ago it may have taken a team of highly trained scientists $100,000 and months to produce a virus, we're rapidly approaching a world where a single actor from anywhere could find the information of a deadly virus online, take that code and reproduce it using affordable genetic sequencing tools and a portable DNA printer that fits on a desktop.
Look how many people have been killed just during this pandemic. SARS-CoV-2 is 1% lethal. Some viruses are 30 or 50 or 60% lethal, so that means 60% of the people who are infected will die.
Synthetic biology, of course, is a dual-use technology. It can be used as a force for good, but also can be quite threatening. And once you let the genie out of the bottle, it's very difficult to put it back in. And we've already seen a very dramatic episode of that when back in 2018, a Chinese scientist used CRISPR editing technology, gene editing, on human embryos.
Two beautiful little Chinese girls named Lulu and Lana came crying into the world as healthy as any other babies a few weeks ago.
He Jiankuai stunned the scientific community with the claim he pushed the boundary no one else had. He says he genetically edited human embryos, not just for research but for implantation, leading to the world's first births of genetically altered humans, baby girls born in China from embryos designed to be resistant to HIV.
For this specific case, I feel proud actually.
He claimed that can prevent the baby from being infected by HIV. So that's technology-wise, I think that's viable, but ethical-wise, that's not allowed. So the scientific community need regulations, particularly those novel technology. You need a regulation in place. Otherwise, some crazy people will do, something you don't want to see.
The incident created international condemnation, and China would sentence the doctor and his staff to prison sentences for violating Chinese medical law. But as it stands, there is no effective international oversight for biotech. The world's biosecurity treaties and policies were designed in a Cold War era of state-directed bioweapons programs, not small groups or even single actors. In the West, some biohackers are not only selling CRISPR kits for less than $200, but have live-streamed injecting themselves with experimental therapies.
This will modify my muscle genes to give me bigger muscles. Ooh. I don't know why people don't try it. I'll let you know how it works out.
Ethical questions exist in the military as well. In December of 2020, John Ratcliffe, Donald Trump's intelligence chief and a former Republican congressman from Texas, alleged China had conducted testing on members of its military in an effort to develop biologically enhanced soldiers. Ratcliffe, however, didn't provide any evidence of his claims, which China labelled a miscellany of lies. AI too poses a potential dual-use threat. A team of researchers recently demonstrated how easy it was to repurpose AI used to help discover new drugs to instead discover potential new chemical weapons. In just 6 hours, the AI had identified 40,000 potential new toxins. But for those invested in this field, they believe the biorevolution can happen without the apocalyptic outcomes.
Well, when we were creating the internet, we weren't thinking about cybersecurity. It's actually a relatively new field. So now that we're in the infancy stages of synthetic biology, we need to think about biosecurity and bake that in right from the get-go.
Experts point to measures like removing public access to sensitive data on some of the worst pathogens, creating safeguards around what DNA suppliers are allowed to provide, and designing defenses into DNA synthesizers themselves to recognize dangerous biomaterial before it's produced. But to build these successfully, the US, China, and other countries will need to come together to make sure these preventative measures are put in place. Not an easy task by any means, especially with geopolitical tensions escalating higher than at any point since the Cold War. But if we're going to be able to reap the benefits of this biological revolution, measures will need to be put in place to maintain confidence in the technology.
Confidence and gain confidence from the public population is very critical. Without those confidence, actually in a way that you will hurt or harm the whole industry.
A good example is the nuclear security summits that President Obama led, and well over 50 countries participated in those. And we made a lot of progress, even with countries like Russia and China. It's perhaps a little harder in this age of division and polarization, but we need to keep at it because essentially these are global issues and no single country can deal with them.
The coming biorevolution brings with it great promise and peril for humanity. Unraveling the secrets of cells and microorganisms could extend our lifespans and set the stage for a more sustainable global economy. Yet, like all transformative technologies in history, there's a geopolitical dimension as well. China's economic ascendancy and competition with the West mean leadership in biological innovation will be contested. Just how this all plays out will be one of the more remarkable political and economic stories in the decades ahead.